What I want to show you now is a completely new technology that we've been developing here at Microsoft Research in Cambridge. And so what I'm going to do is take this is a regular laptop computer that we've modified, and I've been showing you it's running Vista in the traditional mode, but what I want to do now is just switch the mode of operation of this computer to show you our new user interface. So what we've got here on the screen is actually a little carousel of pieces of media. There's a couple of pieces of movie, and there's a couple of just images. And what we've done is we've taken the traditional touch screen, but rather than putting a traditional overlay in front of the screen, we've actually added some electronics behind the display, which gives us the capability of doing much more sophisticated interactions directly with the display. So for example, if I want to move this carousel of media around, I can just put my finger on the display and gently slide it across. In order to change what I'm looking at, I can spin things around, for example, with these very simple gestures. So if I, for example, move around to this one here, another form of interaction we support is the notion of just zooming it, right? So if I can't quite see it and I want to make it bigger, I can just use two fingers to stretch it or to reduce it in size. And I can spin it around as well, for example, by using two fingers. So with a conventional touchscreen, people have come at the problem from the direction of thinking, well, how do we replace the mouse? You know, the mouse is a single pointer, and if we want to interact directly with the screen, all we need is a technology which essentially replicates that single pointer. So I can use my finger as that one pointer. What we're doing here is actually instrumenting the whole screen so we can get an image of exactly what's up against the front of the screen. So there really are no rules. You know, what if I want to put 10 fingers on the screen to interact with it? So what we've done is rather than putting an overlay in front of the screen, which is one common way of doing of implementing a touch screen, and where that overlay can only sense one point of contact, we've actually put some electronics in behind the display, which lets us essentially image through the display and see anything that gets close to the front of the display. So if, for example, if you look up in the top of the display here, as I put my fingers down, you can see multiple contact points being generated, and I can do that for as many different fingers as I want, for example. And so that lets us get the raw data, as it were, the information about exactly what the user's doing when they interact with the screen. And then really we're just beginning to explore the interaction metaphors that follow. You know, so this is an obvious one. You can kind of make things bigger and smaller just by pinching them and stretching them again, or you can spin them around by sort of rotating with your fingers like that. But we believe there'll be a number more really intuitive gestures that you can use to actually directly interact with things on the screen. So if there's something there on the screen and you want to move it, well, you just grab it with your hand and slide it. The way this works is, as I explained, we've added a load of extra sensors behind the display. So at the moment we don't cover the whole display. It's just this area here which is active, and that's really just because this is the first prototype we've built, and the next stage is going to be covering the whole display, making the whole display touch sensitive. But essentially what we've done is this was a fairly standard off-the-shelf laptop. We've taken the screen and we've just cut a hole in the metalwork in the back here, and then we've made some circuit boards with our sensors on them, which we push up against the back of the LCD. But it's just essentially it's just a regular liquid crystal display panel inside there. And what these devices do is they shine infrared light out through the display, and then when I put my fingertips or any kind of object close to the front of the display, some of that infrared light is reflected back in. It's reflected from my fingertips, and those devices behind also detect what's reflected, and that's how we generate those images. And because of the technology we're using, which is infrared based, we can actually do another thing with this display, which is communicate with electronic devices. So one way that existing electronic devices communicate with each other wirelessly is through infrared communications, and we can do exactly the same intrinsically because we've added this infrared capability to our display. So this is actually a standard television remote control which uses infrared normally to signal to the television you want to change a channel. But just to demonstrate what we can do with this, if I fire this towards our display, you'll see the information at the top that we're picking up, the information that's being transmitted, and we can actually control our display using this device. So another example application, this is just for manipulating a photograph. So we've got an image here. Now traditionally you would have a mouse, a pointing device like a mouse, and you could use that to move the photo around. But if you want to do anything more sophisticated, you probably have to go to a menu item and say I want to put it in rotate mode, and then use the mouse to rotate the image, for example. Whereas with our multi-touch interaction, not only can I move this around just by touching it with my finger, but of course I can make it bigger and smaller and spin it around in the same way. So it's just really another example of the sort of interaction that we support that's very intuitive with this multi-touch technology.